All right, so today we're going to look at a couple more types of reactions, and I want to be clear, which is that, like, in no way, shape, or form, I mean, I know I've said this 100 times, but I just want to say it 102 times. In no way, shape, or form am I giving you the list of all the types of organic reactions. All right, organic reactions. Remember when we said, like, ionic compounds are simple, the big dumb rocks, whereas covalent compounds are complicated? The result of that is when we learn inorganic reactions, they're relatively simple. There's single displacement, double displacement, decomposition, synthesis, right? And it's because you're working with simple compounds, your reactions are pretty simple. With covalent compounds, we said they are big and complicated and they'd be put together a million different ways. That doesn't just mean that the compounds are complicated. The logical conclusion of that is that they can have a lot of different reactions. Does that make sense? And when I say a lot, functionally infinite, right? If you can build anything that's possible, then there's got to be kind of any type of possible reaction. So I just want to stress that, like, we are just dipping like our pinky toe just ever so slightly into the water of organic chemical reactions in this unit. Does that make sense? In second year chemistry, usually in most schools, it's a second year class. You can take a whole year long course in organic chemical reactions that will make you question your will to keep on going. And then you will have dipped like maybe a whole pinky toe into the water. You know what I mean? Because it's just an incredibly complicated topic, right? Every time you learn about something in bio class and you learn about something that happens in the cell, that's an organic reaction happening, right? Like so when you learn about photosynthesis, anyone who's taken that course, and you learn all those steps of like oxidative phosphorylation, when you learn about cellular respiration, all that jazz, there are all these big multi-step reactions. That's like step after step after step. Those are all organic chemical reactions, incredibly complicated. Does that make sense? So I just want to stress, we're just like, just dipping our toes in, being like, oh, the water's nice. Water's nice. I like organic chemistry. And little do you realize, piranhas. No, I'm kidding. Organic chemistry is hard, but like it's one of those things where its bark is worse than its bite. And if you don't let it grind you down, if you don't let it convince you that you're not clever, in second year when it kind of gets a little bit hairy, you'll actually be fine with it. And especially, part of why I struggled with it is I'm very much not visual spatial. But if you're a good visual spatial thinker, if you're good at kind of drawing things, if you're good at kind of picturing things in 3 dimensions, if you're good at working with things in that way, if you're good at working with your hands, then you in particular probably will thrive in organic chemistry. You'll do well. I was more poorly suited to it. That's not my strength. I'm more of an algebra guy and less of a kind of able to picture things guy, unfortunately. Anyway, that's the end of my note on that. By the way, I know I said we are going to do a lab today. I forgot to take into account baseball game in which I was very interested in, up till 3 a.m. making test for my grade 9s, which meant I did not get here at 10 to 7 like I'd planned to get your lab all set up. So we'll do that tomorrow, where I will get here at 10 to 7 and get your lab all set up. But I apologize for lying to you. I have no good excuse. And you should probably take late marks off me. I mean, I don't know what that would mean, but like, because at the end of the semester when I give you my evaluation, you can say late marks in unit 2. Shame on you, Orlando. All right, let's get to it. Condensation and hydrolysis reactions. These are reactions that would fall under the category of synthesis reactions in sort of your grade 10 and grade 11 understanding of chemistry. Does that make sense? So a condensation reaction is going to be considered a type of synthesis. What does it mean when we talked about synthesis reactions again? Yeah, combining 2 elements, or not elements, that's combining 2, well, in this case, we'll say what they are, 2 organic molecules into 1. And in the process, we're going to learn about 2 new kinds of compounds. So the first we're going to look at is what we call etherification or etherification. We're going to form something called an ether. An ether. And this is new, but I want you to take a look. And before we learn about an ether, I want you to actually just see what an ether is. Because this is actually, you're going to, I promise, this is what I mean about organic chemistry not being so scary. We're going to draw this, and you are going to tell me what the reaction is. And I promise you're going to be able to do so. Does that make sense? Do you trust me? I trust me. Okay. So methanol, what's methanol? Yeah, CH4. Not quite, but you're on the right track. Let's draw it. Carbon wants to make how many bonds? 4. One of them, since it's methanol, has to be... Yeah, there we go. And then the remainder are hydrogens. Okay, that's methanol. Why do I not have to call this methanol? Yeah, because where else could it be? Obviously nowhere else, right? Okay, and we're going to react that with ethanol. And what's that? Yeah, very good. So it's a 2-carbon chain. And I'm going to put the OH here. And I'm going to do that because it stands to reason that if these two things react, bless you. I don't know why I said bless you when you just coughed, but well, you know, because I hope God blesses you. That's why. Anyway, maybe just totally unrelated to your coughing. Maybe I just, you know, generally speaking, hope that God blesses you. Not maybe, I do in fact hope that. So anyway, there we are. Where's the reaction going to happen? The functional groups, right? I mean, that's why we call them the functional groups. They're the kind of most active parts of these compounds. So those two functional groups, if they bump into each other, if the reaction geometry is correct, so these two things bash into each other, OH to OH, what do you think could happen here? What jumps out at you? OH and OH bumping into each other. Water. Excellent. Now, if we wanted to form water, so if these two things, if the collision happens here, right? If the collision happens here, that would give you a water, wouldn't it? But what's left? Very good. So this would be the reaction site, or the attack site, if you want to call it that. And what we're going to be left with on the other side is that OH stuck to this H. It's going to give us a water. But, and if you're writing this way too big, if like me, you kind of let yourself get a little out of control, you can always, of course, just circle it and just shrink it down a wee bit. That's better. Anyway, you should probably do that. What about this now? That carbon still needs to make a bond. What's it going to make a bond to? This oxygen, because it needs to make a bond. And so what you're going to end up with is this first CH3, and then it's going to be making a bond to an oxygen, which will then be making a bond to this second chain here. Now, if you look this up in the old textbook I gave you, it will tell you that this is called methyl ethyl ether. But we're going to learn this as something called methoxyethane. Methoxyethane. In either case, this is a type of chemical called an ether. An ether. And an ether is Well, the best way to describe it is it's a side chain connected to the main chain by an oxygen.
Is the smaller one considered the side chain?
Yes, very good. Unless there's a second functional group on one of them, then you would automatically call that the main chain. And if they both have extra functional groups, then it gets indeterminate, then it gets messy. We won't even deal with those. Do you know what I mean? But yes, very good. So in this case, we would call this methoxyethane. And again, it is worth noting, you will see an old form. It's not incorrect, but it's not ideal. But just be aware. You will from time to time see where they just name the two chains, they put them in alphabetical order, and then they tell you it's an ether. So ethyl, methyl, ether.
What does the N mean?
Note bene. Note well. Make note.
Is it also Latin?
That is also Latin. Or maybe it's definitely Italian. I wonder if that, I've always assumed it's Latin because these things usually are, but then I just said it in an Italian accent and it occurs to me that that's Italian. But Italian's a Romance language, so it comes pretty closely from the Latin. Now I'm going to have to look it up. I will look that up and get back to you. Anyway, note well, basically. Make note. Be aware. It's been your Latin lesson for the day, possibly your Italian lesson from the day. In which case you can say, note bene. Note bene. Giuseppe, he likes the pasta fagioli.
Why should we be learning more languages?
That's how you speak Italian, by the way. You just speak English, but you say it, well, going like this and be like, hey, hey. You say, hey, ma, do my laundry. Oh, sorry, I shouldn't have said that. Anyway, that was inappropriate and I apologize. But it also describes every one of my Italian male cousins. I had a cousin who went to university, and he would come home on Sundays with a big garbage bag of laundry, which he would drop in the front of his just by the front door, and his mom would start doing his laundry. And then he would also bring a big garbage bag of all his dirty Tupperware, and mom would then clean that and then send him off for a week with clean laundry and a bunch of frozen food for the week. And this was just a weekly recurrence. And I just thought, this man's going to be an engineer. This man can't clean. This man is an engineer now, but I'm this man can't do his own laundry. Right? See what I'm saying? You want a bridge made by somebody who can't figure out how to do his own laundry and make his own food? I don't. Right?
He has more time to be focused
right?
on engineering.
You know what? Here's the deal. Can I tell you something? I reject that argument. I just do. I just reject the argument that by being lazy, you're actually just making time to be better at other quote unquote more important things. You know what I think it's like anything else. You know what I mean? It's you think top tier students tend to also be good athletes and play 3 instruments and volunteer to help the needy as well. You know what I mean? It somehow seems impressive people seem to find time to be impressive in multiple spheres. And schlubs tend to find ways to be unimpressive in multiple spheres, But I don't know. Anyway, he's a good guy, my cousin, but I remember seeing that and being this is good. I just imagine going to my mom and being hey, ma, do my laundry, and she'd smack. She would knock me unconscious. Right? She would, I wouldn't, but I would never dream of it. I remember when I was 13, my parents sat me down to have the talk, and I was oh God, what's this going to be about? And they're if you like things, you need to get a job because we're not spending money on you anymore. I was okay, good to know. And they were not bluffing. They meant it. So I went and got a job. Anyway, moral of the story is.
He's still that way?
Sorry?
Is he still that way?
My mom, is my mom that way? Kind of. He's a great guy. He's a great guy. and like he's very smart and very capable.
Does he do his own laundry?
But I don't think so.
Does he get his wife to do it now?
He's not married.
Oh.
Maybe that's why.
I don't know. Anyway, I wouldn't marry him. That's for sure. Good guy. Wouldn't marry him. Anyway, that's true. Be a little weird, wouldn't it? People would talk. My wife wouldn't be too happy about it. Anyway, all right. So.
He'd become like a very talkative teacher, you know, like, hey, you guys know land
People would talk. This is what I'm saying. By the way, for this to happen, we need to be in the presence of a strong acid. And as a rule, when we're looking for strong acids, that is very often sulfuric acid because it's cheap as nails. I was just talking to a different cousin of mine who does do his own laundry and is also an engineer. A lot of engineers in my family. My cousin Peter just got hired as a chemical engineer and like making more money than God down at a startup mine in the United States where they're mining rare earth metals. But he was telling me that they were coming up with methods for extracting and purifying rare earth metals, and they're using a chemical basis. So it's not like you imagine where you go down to mine and there's like a chunk of metal like this, and you pick the chunk of metal off, and there's the chunk of metal. Like these are metals that are inside of ores, big dumb rocks, right? So you know that metals form ionic compounds are big dumb rocks. And he was saying that like the ores they're mining are pretty good. They're like 30% rare earth metals by mass, which is huge, but you still have to get the metals out of them. So anyway, he was saying that they had come up with this whole thing, and the best method is using hydrochloric acid to extract them. And then they found that they could save per year $16 billion by using sulfuric acid instead. So they said, well, you have to do that. So figure it out. And he said, okay, because it's just much cheaper and easier. It's an industrial byproduct. So in the process of making gasoline and oils and things like that, they produce tons of sulfuric acid. So it's actually quite cheap because it's a byproduct of other industrial processes. But like these are the things you have to think about. So anyway, this particular one requires sulfuric acid, which is like the go-to strong acid because it's cheap. So that's how we form, in this case, methoxyethane, right? Where we take methanol, we react it with ethanol, and in the presence of that strong acid, we're able to get this type of reaction. Now we call this, oh my. We call this a condensation reaction. I hate that name. I really hate that name. But obviously, why do they call it a condensation reaction? Because it produces water. All right, that's why. I don't love the name, but that's what they call it. Because it produces this bit of water, we call it condensation. To be clear, that does not mean it's going to necessarily form little drips of water, right? If this is happening in aqueous solution, it's just going to form more water where water already is, right? But there it is. Questions about that? Does that feel okay? All right. I want you to do an example. Methanol in a strong acid. Well, wait a minute. Where's the second reactant?
Just another methanol.
Bingo. What a guy. Look at that. Exactly. It can react with itself. All right, so try that. See what you get.
Wouldn't that have this? Do you not have to specify that there's two reacting with this? Is it just known?
In a single drop of methanol, how many atoms are there?
Millions.
And the answer is more than you could ever count in your lifetime, right? So yeah, you do not have to specify that there's more than one atom. But that's a fair question. It's also worth keeping in mind, because does that mean that here some of the methanol will actually react with itself? And some of the ethanol will react with itself? Welcome to organic chemistry. Now you got to purify and get the one you want and not the ones you don't. Nightmare, right? Organic chemistry is a nightmare. Because every reaction that can happen does happen, and your job is to figure out how to make the one you want happen and make the ones you don't want not happen.
So what would the name be?
Well, I don't know. Shut up.
ester, you did an ester lab with all your.
Yep, we're gonna do that again.
We're gonna do that? Okay.
Yeah, I think so. We're definitely going to do tomorrow. We're going to do a real simple one, which is just we're going to actually oxidize some alcohols, and then we're going to make some aspirin. And if time permits, we'll also do the esters. Maybe I wonder what people would prefer: the aspirin synthesis or the esters lab. The esters lab is fun. It smells interesting. No, I'll make my mind up. Yeah.
Since we have like two methyls, what do we call it? Like dimethoxy?
I don't know.
No.
I don't know. Just do your best, then we'll take it up.
So I know you're very helpful.
I'm very helpful every day.
Yeah.
I would say, even though they are the same, one of them you're going to treat as the main chain, one you're going to treat as a functional group, if that makes sense. Right? Like, in this case, we called it methoxyethane, and we were treating that methoxy like it's a side chain, and the ethane like it's the main chain, right? And I still want you to name this as if there's a main chain and something attached to it. In this case, they'll happen to be the same, but one of them has an oxygen on it. You know what I mean? Just see what you come up with. Yep. Now, why didn't you get the or don't know? I don't know. I'm tired. Now it feels like I'm pairing favorites, but I'm not.
You have to let us, right?
I think they all guessed. Well, I don't know. Anyway. I think you're giving me too much credit for being organized, but I'll take it. Can we agree that these are both methanol? Awesome. And when the reaction happens, what are we obviously going to get then? By the way, you do not need to color code your OHs. I just find it helpful when you're first learning it to kind of see what's what. But what's this going to form? Water. Good. And I'm arbitrarily going to say that it leaves behind the red oxygen, just because I think that looks nicer. So what is the compound that remains then? What's it look like? Carbon, oxygen, carbon. Excellent. And then obviously these carbons have hydrogens affixed to them. Yeah, very good. Very nice. And so we said, in this case, methanol will react with itself in the presence of, of a strong acid. It could be phosphoric acid. It could be hydrochloric acid, but you got to watch out for that because then you will get that halide, like the halide forming. So we tend not to use hydrochloric acid because it likes to do all kinds of other reactions. But it could be phosphoric acid, could be nitric acid, but overwhelmingly you're going to use sulfuric acid. It's readily available, it's cheap, it works well. And it's going to form water, and it's going to form, what do we call this? Well, the main chain is a methane, and the group with the oxygen on it is a methyl group, so it's methoxymethane. Good. Right, and just to show you, oh gosh, okay, let's not show off grades. That's my grades, that's fine, they're fake. Sorry?
You start doing better.
You know what, I'm just skating by, I'm just really, God, I'm just so into TikTok. It eats up so much of my day, I can't help it.
Yeah, you're gonna rock it.
Right?
You film every day too.
And I subscribe to all these like inspirational TikToks that are supposed to give me motivation. I spend hours watching them, and I can't understand why that isn't helping me do my work. I just scroll through them over and over, one after another, and I'm like, that's a great idea. I should lock in. That's a great study tip. That's really great. And I just keep scrolling through them, and I was like, this should really be improving my achievement. And yet here we are. Anyway, I don't know. So you can see there's methoxymethane.
What if there would be like a section on one of these?
Sure.
You name it the same.
Sure. So you stop.
Oh, damn.
God.
Here, go this one too.
I am not your dancing monkey. Thank you.
I know that's what we agreed on.
That I would.
Here you go.
Oh, so you do it for her?
Get out of here. All right. Where was I? There you go. Yeah. So of course you could have
You can get the after class.
Wow. I'm gonna need it to mark your stuff there. Let me tell you, I'm gonna use all the red ink in this. That was good though. 5 comedy points. I was trying to explain baseball to my daughter, and she kept saying, "Oh, they scored 2 more points," and I'm like, "No, they're called runs." She's like, "Runs?" I'm like, "Yeah, it's just what we call it." She's like, "I like baseball points." So then she would just be like saying, like, they need to score 3 more baseball points if they're going to win this game. And I was like, this is uncomfortable. Anyway, it's the end of my story.
Why are they called runs?
Because you run into home plate, right? Makes perfect sense.
So every time you.
What do they call it in, like, football? So boring. Points. European football is, well, yeah, but the points themselves are just called points, right? Like a touchdown is worth 6 points. A field goal is worth 3 points, but they're just called points. That's boring. Basketball, points, boring. Soccer, goals, that's solid, right? Hockey, goals, that's pretty good. In fact, hockey has both goals and points, right? Because the team scores a goal, but the player who scores it gets 2 points. And the player who got the assist gets 1 point, right? So they have a whole thing going on. Yeah, for stats, right? But nobody has stats like baseball. Do you know I have a file on my computer that is 2.7 gigabytes large, and it contains the stats for every single pitch thrown in baseball since 1902. Yeah, because this is what's beautiful about baseball. Ever since they started playing in the 1800s, they've written down what happens every single at bat, and since the early 1900s, every single pitch. The statistics available for baseball. If you're a math guy, baseball, there's nothing. It's the best sport in the world. It's so great. It's a perfect sport. It's just incredible. Oh, it's so perfect. Sorry?
Have you been watching them since the 1800s?
Yes. Yeah.
Like live?
Yeah. Oh, yeah. No, yeah. I am a vampire as it happens.
You are?
You know, nothing till now has been able to kill me, and then teaching you. I don't know if you've noticed, Kartik. I've gotten gray, and I am aging. It's the strangest thing. You're like garlic or something. I don't know. Anyway,
If you're like a vampire, you should 100% be rich at that time. Like, you can't be living that long and not be rich.
Are you calling me a loser vampire? Are you just saying I'm not very good at being a vampire? All right. Okay. No. Okay. Hey. All right. I'm doing my best. I'm doing my best here.
You could have some secret stash we don't know about.
Let me tell you, I don't. I mean, listen, I'm doing fine. Like I'm a lucky man. I got no complaints. I've worked a lot in my life, and my like liquid assets, like that I can spend, pretty much non-existent, right? Because I'm a parent and I have kids. So like if you ask me for like $8 right now, I'd be like, yeah, sorry, I don't have $8 right now. But like my assets they're doing fine. I'm in good shape. I've saved like you're supposed to, and invested like you're supposed to, and stored away for retirement. I've got all my funds set up, so I'm doing fine. Like when I die of a heart attack, my children will be just fine. But yeah, in terms of like, it's an interesting thing of like even rich people, like it's not like they have money that they can necessarily just turn around and spend, right? Like they own companies that are worth a lot of money, and they own assets that are worth a lot of money. But it's not like that necessarily means you have a lot of money in the bank. And so if you're a normal person, of course, where does most of your equity live? Like for most middle-class people, for most middle-class people, most of their equity is in their real estate, like the home they own and they live in, right? Which is great. Like it's a source of wealth. It's a place where it grows in value, it accrues, but it's not like you can go to the store and be like, you want 1/16 of my living room for that food? You know what I mean? Like it's not money that you can spend now. It's money that is, and that's likewise if you're invested in the stock market, that's great. It's good. Like that's building you wealth, but it's not money you can spend right now because it's invested in a company that's using it to do what it does, right? And if you've got RRSPs, that's great. That's important, right? You want that. But that's not money you can spend now. I paid into a pension. That's great. That's important, but it's not money I can spend now. That's all money for future Joe. So today, Joe is wealthy, relatively speaking, but broke. Which is fine. Nothing wrong with being broke. As long as, listen, can I tell you the trick? Whether you're a vampire, human, or any of the other, anyone who spends less money than they make is growing wealthier every day. Simple as that. And anyone who spends more money than they make is growing less wealthy every day. It is that simple. And so you can be a doctor making $500,000 a year, but if you have an expensive car habit and you love to go on expensive vacations, you're spending $550,000 a year and borrowing it against your assets and house and things like that, you're growing poorer every day. On the other hand, I was a waiter making $6.40 an hour at a time when a typical tip was like 10%, and I worked at a place where you could get dinner for $7. So I used to make like a quarter off this table, a loony off that table, maybe a toonie, and you'd be like, oh my God, a $2 tip. I'm living at large. And I bought a house and bought a car and saved for my retirement. You know what I mean? Because it's not, you just serve a lot of tables. I worked hard. I worked 7 days a week for years. But the point being, if you're spending less money than you're making, you're getting wealthier. If you're saving and putting money away, it doesn't matter. It might be happening slowly, but that's how it works, right? On the other hand, if you're spending more than you're making, you're going into debt. Doesn't matter how much money you make. So even now, when you get a job, you should be saving at least half of as long as you don't have expenses, as long as nobody's making you pay rent and things like that, you should be saving at a minimum half of every paycheck. And that should go away for future you. And if you're not, and you're like, wow, I'm ordering skip the dishes every day, and I'm taking an Uber places that I could easily walk or take the bus because I'm made of money, you're an idiot. But you're save now. It will never be easier to save than it is now. I promise. Just wait. Sorry? No, it's so funny now. I'm so bad with money now because I make decent money. I was so good with money then because I didn't have any, right? So I had to be good with money, right? I had to be so careful because it was like, I used to put cash in envelopes, and that was, we had a series of envelopes, and it was like, all right, we got $38 for food this week. That's what we have to spend. Let's go. And like, if it ran out by Wednesday, you're like, all right, let's see what's in the freezer. Let's see what's in cans in the cupboard, right? And it was like, this was how much gas money we had for the week. Like, it was just and now, like, I'm brutal. I don't think about it. I'm like, just tap. Because I make enough that I don't have to worry about it day to day, which is nice. But on the other hand, it does make you a little lazy, right? It is nice, to be clear, but I don't make enough that I can be stupid. Like, I don't make enough that I can be like, oh, I want that, I want this, I want that, let's go on a trip, like that. Isn't how life works. But I can live frugally and not have to think about money every minute of every day, which is nice. Because man, when you're young and broke and married and have a kid like I was by 22, which is pretty stupid and still in school and whatever, like every dollar you spend, you're like, oh gosh, can we afford this? Can I afford this $3 of gasoline I just put in my car to try to get me home? I don't know. Right?
Orlando, you just dropped a lot before. Did you just say you were in school and had a kid?
Yeah. I had my first kid when I was 22. Wouldn't recommend. It was hard. It was hard work. That's not as young as some people, obviously, but still pretty young. And yeah, we were both still in school. I used to take Greg to, I had to take him to lecture on Wednesdays. We mostly had babysitting taken care of, and for some reason on Wednesdays we couldn't, so he came to Brock with us. And we would try to arrange it so that like somebody was with him, and my friend Tara helped out a ton, my friend Greg helped out a ton, my friend Chris helped out a ton. But every once in a while there'd just be nothing for it, and I'd have to take him to lecture with me. And I had this one lecture with this professor, Dr. Scandalis. He's still at Brock. It's funny, all the first year bio students have him right now. They're like, this guy's horrible. He's a great prof, but he's a tough guy. But anyway, he would just glare at me as I had this baby in a car seat. And Greg was colicky, so he'd cry unless you were swinging him all the time. So I would sit on the end of the aisle and just swing him like this. Be like, oh gosh, I'm dying. And try to take notes with my professor, like glare. Meanwhile, I took him to another chemistry class, and the prof was like, give me that baby. He's like, oh, you come with me. Don't, like, why do you want that? Like, he was so helpful. And then Scandalis would just be like, ugh. So anyway, and then he'd be asleep, and I'd be like, oh, thank God. I'd put him down. Go to right, and I'd be like, oh, thank God. And like 30 seconds later, he'd be like, ah! And Scandalis would glare at me and go, oh God. No way to do things. Let me tell you, there's an order in which you want to do things to make your life easier. Finish school, then have kids, definitely an easier way to do things if you want some advice, some life advice. All right, let's look at the next type of thing we can form, which are called esters. And again, you're going to tell me how this forms. We have methanol here. We'll put it here. And to make it methanol, it needs an OH group, right? And we're going to do ethanoic acid. What's that look like?
Oxygen.
Yeah, you're right. I'm going to do it occurs to me I want to do the H3 over here, but you're right. And then what's on this group if it's ethanoic acid? A double bond to oxygen and OH. Now, I've already spoiled the answer with color coding, but where's the reaction going to happen? Yeah, this hydrogen is more vulnerable as an attack site than this double bond to oxygen. Does that make sense? This is a stabler bond than that is, and so the stabler bond won't be attacked, the less stable one will. So the reaction is going to happen here, right? Which I'm going to show thusly. Is that showing up? That's not showing up great, but that's all right. And what's the result going to be? This is just like the last one. Yep.
Why would the O this time stay there instead?
It doesn't matter which O stays.
Oh.
It actually does in terms of there's a way it happens, but you don't have to know about that. One of the O's will stay. That's a great question, by the way. So what are we going to get? Yep, absolutely. And we're going to get the water, right? And then we're going to get that CH3, the original CH3 from over here, and then an O between them. And then here, this C still has what? Oh, whoops. Because I'm dumb. Like that. Thank you. What's this going to have? A double bond up to oxygen, right? And I should color code this. This is that oxygen from there, right? And then we can keep going. It'll go to the CH3. This is exactly like the other thing, only that double bond to oxygen is still present because it was there when this was ethanoic acid. We don't call these ethers, we call these esters. Okay, so this is methanol, and it's reacting with ethanoic acid. And when we name the ester, obviously we're going to get water. And then when we name the ester ethanoic acid, whichever was the carboxylic acid, that's your main chain. Doesn't matter if it's longer or shorter. That's the main chain, all right? The one that used to be the carboxylic acid is your main chain. So in this case, the ethyl is your main chain. And instead of calling it ethanoic acid, we're going to call it ethanoate. And we're just going to call this a methyl group. We don't call it methoxy here for whatever reason. The O is considered part of the ethanoate group. So we would call this methyl ethanoate. All right? Methyl ethanoate. And this one is 2 words, to the best of my knowledge anyways. Maybe it's not actually. I got to look that up. So the methyl is the one that was the alcohol. And the one that ends in ethanoate is the one that was the carboxylic acid. The carboxylic acid becomes the main chain.
Is there a hyphen between the 2 words?
No, I think it's actually 1 word. I think I lied to you right now. We're going to go check.
Stop wanting to.
Can't stop, won't stop.
Is it the O8 or is it just the
O8.
O8?
Methyl ethanoate. Not ethanate, ethanoate. So methyl ethanoate. Yeah, 1 word. And there it is. Note that the double bond oxygen is on the one that is given the O8 name. Methyl ethanoate.
How would it be different? Like, what if you were like methyl methanoate?
In that case, ethyl methanoate would look like this. Ethyl group,
The double bonded oxygen would be on the
right, to oxygen, and then the methyl group would have that, right? and this would have 2 hydrogens. Yeah, there you go. So that would be ethyl methanoate. Good question.
Is there any side chains of that?
Boy, it gets messy. We're not going to worry about that for now. I mean, the answer is you just do, but it gets messy. So we're just going to,
Like how we didn't talk about chains on chains.
yeah, we're just not going to talk about it for now. You can do it. There's a naming system. It also doesn't come up all that much, in as much as when things get really complicated, we tend to have even more complicated naming systems for them rather than just using the base alkane. So, for example, sugars have their whole own naming system. Proteins have their amino acids have their whole own naming system because they get big and complicated. Does that make sense? So anyway, it's a good question. I'm going to punt it if that's fair. Try this one. Propan-1-ol reacting with methanoic acid. Propan-1-ol reacting with methanoic acid. Howdy. It's like a serious lens. It's crazy that my hand is like practically beside this thing, but I can see it through the lens.
You still see it?
Yeah, it's wild. This lens is super wide. Comes from one of these projectors.
Have you done a skeleton diagram for these?
Oh, you just that's a great question. So this one up here would just be, it's sometimes helpful to just start with the oxygen, and then literally you just draw the carbon on this side, right? Then over here you draw, and like you'll want to go at an, it's always easier at an angle, right? So like that, and then this one will have a double bond to oxygen, and then another down there. Just like that. Wonder what's being really weird with my eraser today. It's the end of my story. I mean, it is. It's just doing it very slowly. What's propan-1-ol look like? 3 carbon chain. Do you want me to do this one as a skeleton diagram? Would that be kind of useful to see that? Okay. So 1, 2, 3, and then it's got the alcohol group, right? And we're going to react that with methanoic acid. So that's just 1 carbon, right? Making a double bond to oxygen and a bond to hydrogen, right? Where's the reaction going to happen? There, right? So this is, we'll just make a note here, this is propan-1-ol. And this is methanoic acid. And on the other side, we're going to get water, and we're going to get, well, we're going to get that propyl group, 1, 2, 3, and then it's going to make a bond to oxygen, right? 1, 2, 3, oxygen, carbon, and that carbon's going to make a double bond to oxygen as well. This one looks weird, right? Because you've got kind of this spot here. But if you're counting the carbons, that's carbon 1 of the main chain, making it a methyl, and that's carbon 1, 2, and 3 of the side chain, making it a propyl. Yeah.
Do you think you could real quick draw like just the last part, like propan?
Do you want me to draw it as a full thing as well?
Normal thing,
Yeah, I'll draw the whole thing as a full thing as well.
Oh, okay, thank you.
Useful to see it both ways, I think. Yeah, if you want to see this as a full structure, it would look like this. And that's a carbon making a double bond to an oxygen and a bond to an OH. And that's only 3 bonds, so it'll have a hydrogen here as well. And that's going to form water. And it's also going to form carbon, 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 oxygen, carbon double bond to oxygen. Shh, guys, you asked me to draw this. Now you're talking? Be quiet. I'm going to move that water because it kind of looks like it's stuck to that. But my computer is going to be like, oh, you want to erase something? No problem. We'll do it one line every 12 seconds. Hello? Hello? There we go. There we go. How's that? Okay? Cool. And what would we call this? What's the main chain? Sorry? Yeah, not propan, propyl. But that's okay. Propyl, which is how we've always named a propane side chain, right? And then this is not just methane, it's methanoate. So propyl methanoate. And again, if we put that into mole view, it should pop right up. Now, if you can put something together, then you can also take it apart. So if we can put these two things together, then we can also take them apart. And in that case, we call this a hydrolysis reaction. And if you think about it, it's going to make good sense because we're going to use hydro, which is, of course, water, to lyse something. And lysis means what? Break apart, like cell lysis, right? So breaking apart with water. So propoxybutane. Propoxybutane would look like what? It'd be 1, 2, 3 carbons, right? And that's going to bond to an oxygen. And then butane is 1, 2, 3, 4 carbons. That is propoxybutane. Do you want me to draw this one as a full thing as well? Is that more useful? Okay, we'll do that. It's going to be a lot of carbons, but that's okay. I love you.
We love you too, Orlando.
Thank you. That means everything to me. Now, when we want to break this chain apart, it's just what we learned about putting them together, condensation reactions, but in reverse. So where is the water going to attack? Yeah, the attack is going to happen here at this bond. In fact, specifically, it's going to happen at these two bonds there, right? Right? We could pick one arbitrarily. I'm going to pick the one on the right. Doesn't really matter, right? But that bond's going to break, which means this oxygen's going to need to make one more bond, and this carbon's going to need to make one more bond. So what will we get on the other side? Well, we'll have this propyl group, right? So we'll have C, C, C with all of its H's. But now we're going to say that it took the oxygen with it. So it's also got this oxygen here. It doesn't matter which one you say took the oxygen, but that oxygen wants to make another bond now. What's it going to be bonding to? Hydrogen. Specifically, like, say, this hydrogen right there, right? And then, what about on the other chain? Well, on the other chain, we're going to have, I'm running out of space. This is a big molecule. And then, on the other hand, we're also going to have that 1, 2, 3, 4 carbon chain with all those hydrogens. But now that carbon wants to make another bond because we just broke one of its sigma bonds. And what's it going to make a sigma bond to? OH. So there should be no surprise there because it's just the condensation reaction in reverse. So and what kind of compound is this again? This is an ether, yeah. An ether breaks down to give us an alcohol and an alcohol.
Is that how you spell it?
No. There we go.
And esters breakdown?
Ah, I'm so glad you asked. Yeah, esters, of course, can break down, but they won't give you an alcohol and an alcohol. An ester will give you an alcohol, and a carboxylic acid, which is like an aldehyde, but it's also got that alcohol group stuck on it. So when you have an aldehyde and an alcohol group both on the same carbon, we call that a carboxylic acid.
Is an aldehyde just the one with the double bonded oxygen? And
That's right.
wait.
Yep.
Okay.
Yeah, so it's like an aldehyde with an alcohol is a carboxylic acid.
Also, Orlando, real quick,
Yeah.
I still don't understand like the last question with the ester.
The one we just did?
Yeah, like I don't know how to make a skeleton diagram.
If you want to make a skeleton diagram of this? Oh, no problem.
Not this one, the one before. I just want to know how.
Like what? Like this is 1 carbon, 2 carbon, 3 carbon, and then an OH group, right? And then this is 1 carbon, making a double bond to oxygen and a bond to OH. And then over here we have 1, 2, 3 carbons, then stuck to an oxygen, which is stuck to 1 carbon, which is making a double bond to oxygen. Does that make sense?
Yes.
But if the skeleton diagram stresses you out for one, just draw it the other way. It's a bit longer, but you can always do it. Yeah, I think I just put the same questions on here this time, but now you can do them. So that's exciting.
Yeah.
Sorry?
These two methyl group and one.
Yeah, so draw it.
We can still draw it, but we cannot name.
Try naming it. See what you come up with. It's okay to do something you haven't been taught how to do and just try it, and then we'll take it up. You'll be okay. You're tough. You could even go to MolView, punch in your answer, and see if it gives you the right structure. And if it does, you'll know that you've named it correctly. And if it doesn't, you can try a couple other things. And then like, don't beat yourself up. Like, but at a bare minimum, you should be able to draw it. And then try naming it. See what you come up with.
The naming ones with Tuesday on the test.
I don't know. I haven't made the test.
Oh.
Keep asking annoying questions, it will.
Okay.
That's a joke. Oh, I had stuff to give you guys back. That's just been sitting on my desk. Bugging me.
That's
What?
not ours.
Quiet you.
Oh, sorry. That's
Kartik, come here. There you go. Evan, come here. I don't know why I didn't give these back to you like forever ago. Presumably because I'm a failure as a teacher. Kartik, come back.
Oh, am I in trouble?
No. In fact, I think you'll be quite pleased with this.
Oh, thank you.
Mila, come here. You're here. Slam Brady, come
I
here.
didn't mean to hit you.
Angela. No, why am I giving you for work? Come on now.
Ow.
Who do you think I am? Oh, there you go.
A responsible educator.
Slam Brady. Yeah.
I'm on my feet. Thank you.
I mean, you're welcome, but don't thank me. You did